This is MATHguide.com. My name is Mark Karadimos. Today we're going to take a look at how to calculate the inverse of a function. Well, here's a function. You can even see it has the f of x function notation, and we're going to calculate its inverse. Now, the directions in a problem like this may be, it'll say find, or it'll say calculate f inverse of x. That may be it. So if you ever see that little -1 power, that indicates that we're going to calculate the inverse. Okay, so those might be the directions that we'll see on a test or a textbook. Alright, well, the first step you're going to do is, well, I'm going to get this out of function notation. I'm going to write that as y. Remember, y is just f of x. We're going to put -3/2 x plus 3. Alright, so there you go. We've got our equation written down. Alright, now there are two steps in actually calculating the inverse. The first step is we're going to switch out the x and the y's. In other words, we're going to swap those letters. Okay, we're just going to swap the letters. Not going to do any calculation to begin with, just swapping them. Okay, so let's do it. Instead of y, it's an x. Instead of x, it's a y. Alright, step one is done. Alright, next step we're going to do, which is going to be a series of steps, we're going to solve this equation for y. Okay, we're going to get the y alone. In order to do that, we're going to do some algebra. I'm going to subtract 3 to get rid of the addition of 3. Alright, so what do we get? We're going to get an x minus 3 on the left side. 3 and the -3 cancel. We're going to get a -3/2 y. Alright, so to get rid of this fraction, since we're multiplying a fraction times our letter, our variable y, to get rid of that, we are going to multiply both sides by its reciprocal. So the reciprocal of -3/2 is going to be -2/3, and that's what I'm multiplying both sides by, a -2/3. Okay, so you can see that dividing by 3, multiplying by 3, they cancel. Multiplying by 2, dividing by 2, everything is going to cancel here, even a negative times a negative. It'll cancel on the right side. So we get y over here. That's easy. Now here we're going to do the distributive property. Okay, everybody should remember that the distributive property says we got to multiply through, right? Because I am, and maybe I didn't make this clear, I guess I should make this clear now, I am multiplying the entire left side. The entire left side by that -2/3. Okay, now it's clear that I'm doing that. Alright, so let's do that. Let's multiply a fraction times x. Well, that's just -2/3 x. Now when I'm multiplying a fraction by a fraction, notice I just put the 3 over 1. You multiply numerator times numerator, denominator times denominator. But I do notice that the 3's are going to cancel when I multiply. So picture that 3 canceling with that 3. Okay, those 3's are going to cancel, so I'm going to get 2 over 1. 2 over 1, and even a negative times a negative is going to be a positive. Okay, so I get 2 over 1, or just positive 2. Okay, there you go. So I have my new equation, and probably good that I write it with the letter being on the left side. So I'm just going to kind of swap it around. Alright, so that's how you calculate the inverse. Alright, now I also want to show a property that's going to occur, a visual property. So I'm going to make this problem here that we started with, this is going to be blue, and then the one that we just saw, let's say I'll make this one in yellow. I think the contrast will be good. Alright, now if I'm going to graph the first one, I'm going to start with the y-intercept 3. That's how you always graph. And then I'm going to go, remember, rise over run, down 3, right 2. Down 3, 1, 2, 3, right 2. So I'm right over there. And I got myself this line. Trying to be as accurate as I can in drawing this. Okay? Alright, now for the next line. You start with the y-intercept, which is 2, and you're going to go down 2, right 3. Right? Rise over run. Down 2, because it's negative. Down 2, right 3. Down 2, right 3. Right, I went down 2, right 3. And now I've got that. Alright, let's see if I can draw that neatly. It's got a very strange angle. Okay, so I'm trying to be as neat as possible to get that line. Alright, now when you graph the two lines, and I do have the original f of x is blue. Remember this one, this is your f of x is the blue one, and then we know the yellow one is f inverse of x. Okay, so now we've got them graphed. Now an interesting property that does exist with this is if you graph the line y equals x. So I'm going to graph that line. If you graph that line, you are going to get this. And I'm going to make this dashed because it's not part of our curve, right? It's not the curve. It's just a visual that I want to see. And when you graph it, you should notice that this diagonal line is the line of symmetry between the two curves. So you can see that the right side is exactly looking like the left side, or I should say the upper left side looks exactly like the lower right side. There is a great deal of symmetry with this line, and this is what always occurs when you graph the line y equals x. Okay, so that is always going to be the case. It's always going to have that nice symmetry across that diagonal line. Alright, so that's how you calculate, and those are the visual properties. Make sure you go back to MATHguide.com, check out all of our interesting interactive quizzes, lessons, and activities. Take care.